Hello, my name is Jeremy Lickness, and I'm a program manager for .NET Data at Microsoft. And I'm here to share with you how to access Azure Cosmos DB using Entity Framework Core. If you're not familiar with Entity Framework Core, no worries. We will explore what that is and explain that and talk about actually several things. Let's take a look at where we're going to go on this guided trip today. We're going to start with why Entity Framework Core. A lot of people who have heard of it know of it as an object relational mapper. So why would we use it for a non-relational database? And that's a great question, by the way. We're going to look at a getting started scenario with EF Core and Azure Cosmos DB. Talk about what's missing. It's not a full implementation of the feature set, so that's important to know. I'm going to go through a playbook of specific concerns or nuances of using EF Core with Azure Cosmos DB, sort of the things to look out for and be aware of. We're going to see an example create, read, update app. And I'm going to close out talking about a cool new technology, Blazor WebAssembly, and the potential to connect to Azure Cosmos DB directly from your browser. So let's get started. The first question I often get is, why do we even care about Entity Framework Core and Azure Cosmos DB? That's a great question. So one of the things we did is surveyed thousands of developers who use Entity Framework Core. And half of those developers, that's 1 in 2, said their most requested feature to add is a non-relational database provider connecting to some sort of document database, either including features in Azure Cosmos DB or some other provider. 1 in 3 are either using now or are considering using Azure Cosmos DB. So that's a lot of developers already familiar with Entity Framework Core who are interested in connecting to non-relational data. So the feedback we get from developers who are using it is they like the ease of the setup. Entity Framework Core provides a lot of conventions and does things by convention. So in the background, for example, your database, your container, all these assets can be created pretty much just based on the syntax of how you define some structures that we'll look at. And here's a quote from Julie Lerman, who's very active in the community with Entity Framework. And she said, "I just provided a connection string and I was good to go." So we'll see how true that is in some upcoming demos. Developers are familiar with the Entity Framework Core API. So they know the dialect and the way of interfacing with the database. So being able to use that familiar set of APIs is important. And there are certainly multi-use scenarios of fanning out. In fact, there is a group internal to Microsoft who is at very large scale using a scenario like this. They stand up an Azure Function app, and that consumes some data. It then takes that data and passes it to Entity Framework Core. What's nice about Entity Framework Core is you can model the data in one way and persist it in multiple ways. So using that same snapshot of data, they're able to write it to an Azure SQL Server as well as an Azure Cosmos DB provider. And what they're looking to do is process the data in different ways based on those work streams, but EF Core helps simplify that process for it. So let's look at the getting started story. And what I want to start with is a getting started application that's part of Cosmos DB. So I'm going to go into this little to-do app. I'm just going to open it up so we can take a look at this. And this is not an EF Core app. This is what the getting started experience looks like using the direct SDK. And what I'll point out is I've got this family class right here. And what we're modeling is a family that has parents, that has children. The children have pets. And then we have our main program. And let's take a look at what happens here. So we've got some secrets that we expose. You would never do this, right, in a production app. For a demo app, we're fine with that. And this is going away by the time you might try to access it. So I'm not too worried about these keys showing here, but just know that in a production application, you would store these environment settings and key vault in some other structure to keep them hidden from prying eyes. We've got the database ID, the container ID. So we create this Cosmos client. This is using the I believe 4.x SDK. Then we create the database, create the container, add some items, query the items, replace the items, delete them, and delete the database. So this is a demo that cleans up after itself. And we can look at, let me get this out of the way. We can look at sort of, here's how we create a database if it doesn't exist. Here's how we create a container. That's a logical place to store your entities. Here we're adding an item to a container. So we're newing up our C# class, and we're grabbing the container to see if it already exists. And if it doesn't, then we're creating that item async. We have this item response that we can use to get back the result of that operation. Then we go through and we do some updates here. This is using a SQL syntax to query from the database based on that last name. We create the query definition, we iterate through the items, show the families, and we do a replace, then we delete an item, and finally we delete the database. So what I'm going to do is just put a breakpoint right here, right before we delete the items. And let's go ahead and hit F5 and run this demo through. So we're building, we're running. And after a little bit of initialization, we should hit my breakpoint, which we are there. And then what I'm going to do is just scroll down here, see what we wrote out to the console, lots of diagnostics information, DB trace information. So it's giving me basically all of the diagnostics of the steps that it's taking. And we got an exception that we were actually looking for. This was when we were loading and bringing something back. But let me go actually into Cosmos DB in the portal, and notice that I have this family database that was created. And if we open this up, we can see there's a family container that has items, and we can then navigate to these items and we can see how they're stored in the database in that structure. So that's why I paused it, so I can show you that. Let's go ahead and let it finish to completion. We'll just go ahead and run it. And what it's going to do is spin through to the end and ultimately delete that database. So let me close this. Let's make sure, get my window here, and let's continue on. Okay, so now we're out of this. So let's close that down. Now let's take a look at what this experience is like with Entity Framework. So I've got a to-do EF app. And do the same thing. Let's open this up in Visual Studio Code. And we're going to look at some of the changes that I had to make for this to work with EF Core. First thing I'm going to point out is in the family. Right now, EF Core does not support out-of-the-box primitive collection types. So this was an array. I'm sorry, primitive arrays. So this was an array of pets, for example. I just changed it to an iList implementation. Anything that inherits from iCollection can be handled by EF Core. So that was a slight change to the model, and that's an issue that's being addressed. The family context is the key. We'll talk more about this, but in Entity Framework Core, you create something called a DB context. This is how you map what your classes are to your database. Now remember, in the previous versions, it was mostly relational, and there's often a disconnect between how relational tables are represented and how the actual domain model is represented in your application. The DB context gives you the opportunity to model how that relationship exists and tell EF Core what it should be tracking. So here we've got a constructor that takes some options in it, and the DB context is reusable and configurable. So I can reuse it in different contexts, even pointing it to different databases. So the same context I can use for Azure SQL and Azure Cosmos DB. It doesn't mean the same set of features are supported, but the basic functionality is there. The DB set is how I tell Entity Framework something is interesting. So I'm telling it, I want you to track family. We're going to persist family. Now, family has children, parents, pets. EF Core is smart enough to traverse that object graph to look at your domain graph and understand these relationships exist. However, coming from a relational background, Entity Framework Core by default is going to assume we're tracking those entities separately. So the children, the pets would all get their own table, because then we can have relationships with the tables. We obviously don't want that in Azure Cosmos DB because it works differently. It's a document database. So what I'm doing here is some configuration. First, I'm telling it what the partition key for family is. So instead of having to do that in my API calls, I can just configure that once in the data context. And I'm telling it family owns parents. So instead of parents belonging on their own as independent entities, they're wholly owned by family, so they should be serialized as part of family. Then I've got family owns children, who owns many pets, and it owns one address. So that's my configuration for the DB context. Let's look at how this program changed now. So we're going to go inside and look at some of these methods. So we have the same endpoint URL, etc. Only this time, to set things up, I use our options builder to specify the endpoint and the key, as well as the database ID. So this is configuring the DB context to talk to that Cosmos DB endpoint. Now, creating the database, we can do, the container is actually created implicitly, and I'll talk a little bit more about containers in a moment. And then we have our other methods. So this is ensuring the database is created. We use ensure created async. This will, if it's created, return a flag that says it's already there. Otherwise, it'll create it and return a flag saying, I just created a new database. To add the items to the container, we create the context. And here I'm looking to see if the family exists, but I'll drill into that in a moment. And then I just do context add Anderson family. The context can track multiple entities. This is another reason why people will use Entity Framework Core. I may have 15 different types of entities that I'm tracking, and I want Entity Framework to keep track of anything that had changes. When I call that save changes async, it's only going to generate updates for entities that were mutated or that changed. So even if it's tracking 15 entities, if I only change a property on one, it's smart enough to just update that one entity. So save changes async is a very important step in this process. Here we're adding another family member, and we just do context add, context save changes. Querying is where it gets interesting. So one of the advantages of the SQL API is you can use that SQL-like syntax. With Entity Framework Core, you can use language integrated query to build up your SQL queries, which is something that the SDK is capable of as well. But here, I'm basically filtering families on last name. I can also do projections if I want to, and some complicated link functionality, basically, and that will get translated to that SQL query dialect and passed to Cosmos DB. So here I'm just turning that link query into a list and iterating through the families. To replace an item, I'm grabbing that item, I'm setting a property, and I'm calling save changes. Because I changed those properties, EF Core is aware of those changes and knows to update that family. Then I've got a delete. I basically set up the key for that item, flag it as deleted, and save changes. And then I have this ensure deleted for the database. So let's do the same thing. Let's set a breakpoint right here. And let's run this application till we hit the breakpoint. And it's spinning up. Give it a second. All right, so we're at our breakpoint. So let's come back to our database. Let's refresh this. So now it's family database EF. We'll expand that. I have family context. So this is the implicit container that it created, and we can change that. I'll show that. And then these are my entries. And if I click on an entry, you're going to see looks exactly the same. We've got children, we've got pets. The pets are in an array, and everything's saved out the same way. So it's pretty much apples to apples with this example. Let's let it finish out so it can clean up. And run it through to the end. So we're going to close this out. And I'm going to come back to my slides and recap some fundamentals. So I covered a lot of information, but to be clear, DB context is the building block. It works like a unit of work. So you can take a DB context, perform multiple operations, then call save changes and have everything batched at once as your update. It handles change tracking. It also handles concurrency, and we'll take a look at that. It hosts the model that represents how do I connect my domain to my backend database engine. And I can fluently configure that. I can also use attributes for some of that configuration, so there's flexibility. It's also an event source for transactions. It emits events when interesting things happen. We'll take a look at how we can tap into that in a second. It's configurable, so it works across providers. It's common, for example, to use an in-memory version of the provider or a SQLite for a light local database for unit tests and other scenarios. But it is important to note that the providers are database-specific implementations, so they understand the nuances of the database. A query that I can write against one database may not translate to the other, and Entity Framework Core will throw exceptions or warnings to let you know when those issues are encountered. That DB set is the important way that I connect the entity to the database. The other thing that's interesting to note is EF Core supports something that we call shadow properties. Shadow properties are properties that EF Core will track as part of your entity, even if they aren't defined on your entity. And what I mean by that is, for example, let's say you have a concurrency tag, which Cosmos DB uses an E tag. You can tell Entity Framework Core to track that concurrency tag, and even though you don't have it specified on your domain class, it will track it. It'll know that this entity is associated with this concurrency tag, which is a really powerful feature. Now in the demo I'm going to show you, I explicitly track concurrency because I support disconnected updates. In other words, I'm not creating a long-lived context, doing a lot of changes. I'm doing very snapshot transactions, which is typical of web applications, but it's good to know. You have interceptors and events, which are like database middleware, so I can plug into the pipeline and make things happen. As you saw with the configuration, ownership is implicit, but then it can be explicitly configured. So entities are typically their own tables or containers or storage units, if you will, but you can override that and say this entity is owned by that entity. The other important thing to note is I mentioned, for example, there's not built-in support with EF Core for primitive arrays. That can actually be handled, it's just not built in, using value conversion and comparison. And I'm going to show you an example of what that looks like as well. Before I dive into the example, it is important to share what is missing. If you're making a decision whether or not to go to EF Core, there's a little bit of a chicken and the egg going on right now. And what I mean by that is we have features missing, but we prioritize features based on your feedback. So for those of you not using the provider because it may be missing a feature, I do encourage you to let us know what those features are so we can build those and make it accessible to you. These are the top voted features right now: that support for collections and dictionaries, include support, and it's not include support, it's support for the include directive, which allows you to specify what part of a document structure you may want to load, from SQL support so you can pass direct SQL queries, configuring your time to live, support for serialization options, and then there's a outstanding issue that's an interesting one, which deals with what we call data migration. So in the relational world, migrations track changes to schemas over time, and they generate the data modification language necessary to update that schema and or migrate the data. With a document database, that's different because you can have multiple schemas. There's no issue with that. But there are scenarios when a schema is modified that you may want to go back and update or change existing schemas. And so there's a discussion around ways to potentially make that easier using the if core interface. I just want to reemphasize, we need your help to prioritize the features. We do everything in the open. We're an open source project. And so we encourage you to go to our open source repo on GitHub. Look at the issues. There's a label called Area Cosmos that tags all of the concerns related to Azure Cosmos DB. Upvote the ones that are interesting to you, file issues if you encounter them, and we would like to respond and talk to you and evolve this provider to adapt to your needs. So let's talk about the playbook, given sort of the scenarios and some of the limitations and some of the ways that he, of course, configured. What should your top of mind concerns be when you're building an application with EF Core and Azure Cosmos DB? Well, like any application, regardless of what strategy you're using to access Azure Cosmos DB, you're going to want to plan your strategy for databases, containers, entities, and I'm going to skip ahead a little bit, but partition keys, right? Those are important. You want to make sure you configure your hierarchies correctly, because the last thing you want to do is have family, pets, children in different containers, and suddenly you have an overhead of joining those different containers together when they should just be owned entities. So you have that option to configure it. You can use toContainer to specify containers, and I'm going to show that. And one of the interesting things and a feature that people like about EF Core is by default, it'll store multiple types in the same container. So if I was tracking parent and pet and child separately, those could be tracked in the same container, and it just uses a discriminator field, which is an internal field that it uses to flag what the type should resolve to. This makes it easy and lightweight to overload. If you query for just pets, it will implicitly insert the query necessary to only load that discriminator of pets. However, there is overhead in tagging that discriminator and adding it to queries. So if you're only storing one entity type in a container, you can tell it has no discriminator and it won't track that. Partition keys are huge. We're going to see how they map into Entity Framework Core. And there are edge cases you'll run into that most of them can be solved through value conversion. So having said that, I want to take you to Planetary Docs. And I had to sneak in my photo of the moon I took with my new telescope. I'm pretty excited about that. But let's look at a sample application. And the scenario looks like this. Imagine if I had a way to manage my documentation. And for our projects at Microsoft, our documentation is in Markdown. It's on GitHub. Most of it is open source, and it's transformed into HTML as we make changes. So what I did with this database is I pointed it at one of our publicly available repos, the ASP.NET Core Docs, and I used it to build a set of tables and structures. And what I loaded was the document itself with like title and description. I have the aliases of the people who edit the documents, and I have tags that are tagged within the documents. So doing that, I can do something like this and find my name and quickly pull up the documents with my name. Then I can click on this little eye, zoom into the document. I see some information about it. I see the title, see that I'm an author. Here's my markdown. Not very interesting. We can show it as HTML. I don't know about you. I'm not great about reading HTML source code and envisioning it. So then we can preview it, and it'll actually do an HTML preview of what that code looks like. The other interesting thing here is we can show this audit history. So it's tracking changes to the document. And I want to show you what that looks like. So you can see there's 3 audits right now. So let's do edit. And I'm just going to change this and put a little space in the title. And we're going to save it. So now we've come back. And now we've got that space in the title. And if I look at show audit history, you can see I have a new modified entry now. And if we come down here, I can go to a previous entry, click on that, and see what it looked like before. So it's automatically taking snapshots for me. So the other thing I'll show you is if we go back to the current version and we edit it, I'm going to create a new tag, and I'm going to call it Cosmos Conf for the Cosmos DB conference. I'm going to add that tag. I'm going to save it. And then I'm going to go back to the home screen, and I'm going to type Cosmos. And notice I have this Cosmos conference. So if I click on that, it very quickly pulls back that document that I just added. It'll do the same thing with aliases. So we have full text search, but we also have search that can be constrained by these. So this is how the application runs. Let's take a look behind the scenes at how it looks configured in the Azure portal. So I'm going to refresh this. Here's my docs context. So what I decided to do was create 3 containers. One container has those audit snapshots. So every time I make a change, it's storing that change here. You can see the partition key is the document it's tracking, and then there's a unique ID. And when we pull that open, it basically has the snapshot of the document. I also have a meta container, and that contains both of my tags and my aliases. So I don't know why the partition key is not showing here, but the partition key is based on if it's an author or a tag and what the value is. So for example, if we look at this ASP.NET Core tag, we can see that over here, it's got the discriminator of a tag, and then it's got this list of documents. And the list is just a summary list. It basically has the alias of the author, the title, and the UID. But this allows me, if I'm searching by tag, to quickly grab that list of documents. In fact, if we scroll down, let me see if I can find the Cosmos Conf tag down here somewhere. Let's look at, oh, that's right. I'm not scrolling all the way. There we go. So we have a fried egg tag. But this Cosmos tag basically just has that one document listed within it. Then we have the documents themselves. And the way the documents are modeled is this one, the partition key is the primary key. So it's partitioned on key. And then if I look at, let's click on this one, what we can see is over here, we're storing the alias, the description, the HTML text, there'll be markdown text. And let me just get to the bottom so you can see the tags is just a list of the tag names. So that is a walkthrough of the database. Now let's do my favorite thing to do is jump behind the scenes and look at some code. So let me jump in here, and I'm going to stop the application so we can walk through what the code looks like. The first place I want to start with is how I modeled my domain. So this is an example class of an author. So the author has an alias. That alias has a list of document summaries. And a document summary is simply the UID, title, and author alias. It doesn't even have its own key. It just uses the UID's hash code for that. So that's a summary object. And you'll see that the author contains that. So this is the documents that this author has authored. But you'll also see that the tag itself has a similar list of a document summary. So that's a structure that is a convenience for that fast search that I can grab it, and we'll look behind the scenes on how that search is implemented. Our document looks like this. So we have a title, description, published date, author alias, a list of tags. And then we have this document audit. The document audit just stores a snapshot of the document, and it actually serializes it into a field and provides a helper method to deserialize it back. Now this is important how this document audit works, because I want to show you some of the ways that EF Core can help automate some of the tasks that you're doing. So now that we've looked at the entities and how these entities are defined, let's go into what is our doc context. And this is our DB context. Now this really should contain configuration information for your database and maybe some helpers that need to be close to the database. And then all of my logic I put into a data access service that has an interface in front of it so I can mock it and test it and do whatever's needed. You'll see here we've got our document audit, our document, and our tag. So this is how we're telling EF Core to map between them. And then we have this on model creating. This is an override we use to fluently configure the internal model of the context. And that model is how it understands how to map between the domain and the underlying structure. So let's look at how we did this. I'm telling it document audit has no discriminator, so it's going to be the only type in its container. It's going to have the name of audits, so that's how I specify it's going in its own container. I tell it what the partition key is, and then the key itself for Entity Framework Core purposes is the composite key of its ID and its partition key. So you're going to see this pattern, composite or actual entity key and partition key is in this definition of has key. Now we're looking at the document. This one also has its own container, so it also has no discriminator. And this one's key is the same as its partition key, so we just use this has key. And then the partition key points to the same ID. And then I'm telling it that the E tag is an E tag concurrency. And that's actually something important to show because Entity Framework Core has concurrency detection built out of the box. So let's spin this up again. And let me pull up my favorite document to pound on because it's the one that I own. And I'm going to hit edit. And then what I'm going to do is just go ahead and take this URL. The nice thing about Blazor is you can have bookmarkable URLs. I'm just going to paste it over here. And JavaScript interop calls, that's okay. What we can do is come back here. I was wiring in some changes to the HTML preview, which requires some JavaScript. So now we've got two tabs that are edit. So this one I'm going to take off fried egg. I'm going to save it. And then this one I'm going to take off app settings and save it. And here we get the document was updated since it was last loaded. You can save again to overwrite changes or reset to reload the document. And now the way I have this application implemented is if I click save, it's going to overwrite. So what we'll see is fried egg is still there, but app settings is not. So I chose to overwrite, but I could have done reset and refresh the data. So that's out of the box. Let's look at how that is handled in the code in a second. So keep in mind this E tag, I'm telling Entity Framework Core, this is what to use for concurrency detection. And then here's where we start to look at some of the edge cases. So I have this list of tags, which out of the box is not serializable. And that's what that issue is for, is to support these primitive types. If it was a complex type, it could handle it. So all I'm doing is telling it has this conversion to JSON from JSON. If I look at those methods, I'm just using the JSON serializer to serialize the item or deserialize it. Just by using this right here, document has conversion. Now we support the tag list, no problem. It's basically gonna serialize it on save, deserialize it on restore, and then I just deal with those domain entities directly. There's also a doc summary converter, because remember we have that list of doc summaries used both by author and by tag. So this one is doing the exact same thing. It's just in the from JSON turning it into a list of document summaries. I'm also giving it a value comparer so that EF Core knows when items were removed or added to the list. It can use that comparison to understand it. And basically, my document summary can be compared based on the UID. So that's exactly what that's telling it to do. Now that we have that value converter and comparer, we can use it. So for our tag, I'm telling it there's a partition key. So one of the things you may have noticed is that on tag itself here, there's no property called partition key. And remember I mentioned the partition key is this hybrid of the type name and the actual value. So this is that shadow property I was talking about. I'm telling it to track this property even though it's not on the model. And I'm telling it it's a string and it has partition key. I'm putting it in the meta container, giving it the key of the tag name and that partition key. So I'm just giving it the name of the property, showing it what the concurrency is, and then passing the converter and comparer to the conversion. So this seems like a bit of configuration, but the nice thing is I do it just once, and then I'm just interacting with entities all day long. I only have to configure this down at the DB context level. The author model follows pretty much the same pattern. And then we have some hooks in here. Remember I mentioned that there's events that you can use and trigger sort of middleware, if you will, and intercept the pipeline. So what I've done here is when this is constructed, I'm hooking into the saving changes event. So I'm telling it right before you save changes, I want you to hand off to me to do some code. Now, just to be clear, there's multiple ways to do what I'm about to show you. Cosmos DB has stored procedures. It has support for different types of triggers that you may want to do at the database level. You might have an event source that's reading changes and doing things. So this is not a prescriptive way of doing it, but I'm showing you if you want code to manage some of the process, this is one way you can do it. So if we go to this saving changes, find that method. I know I could just pop to it from the top. This is looking at the change tracker. So Entity Framework Core DB Context has a change tracker that is the mechanism that handles all of the changes and things it's going to do when you call save changes. So I'm telling it, let me look at the documents that are either added or modified and give that to me as a list. And then for each entry, I'm simply adding to the audits. So the change tracker had a list of documents that mutated. Now I'm telling it, here's a list of document audits that are mutated. And when I save, it'll automatically add those audits for me. So a developer doesn't have to worry about that. This is done automatically behind the scenes. That's what that interception does. And I used an event to do this. You can also create a save changes interceptor, which is a class. So if you want a reusable class that you can multi-purpose, you can do that as well. And then when I dispose, I'm a good citizen, I unhook the event so I don't have an issue with memory leaks. The other nice thing is both the author and the tag are contained within the same container, and they have the same key strategy. So I can actually use something like this, where the T is the class and the doc summaries, and generically provide a find method to find the author or find the tag. So this is just a helper method that wraps that find method. And this one is computing the partition key based on the type and the actual key value. I also have a helper method to set the partition key. Because this is a shadow property, it's not on my class. So when I go to save this, I use Entity Framework to reference that partition key, and then I compute it and set it so it's always there for the value. This happens behind the scenes. So now we can step back and look at our document service. This is the data access service that I built. It's taking a factory. This is something I configure in startup, and we can actually look at that real quick. Right here, I'm configuring factory, telling it to use this Cosmos endpoint and key and the name of the document context. So this is where I inject the factory. What this will do for me is every time I need a new data context, I can just ask the factory and that configuration will come built in. So that gets injected through dependency injection. And yeah, document service is where we were. So that's injected in. Here's my insert document. I create a context, I add the document, I save changes. We'll talk about handle meta in a second. Pretty straightforward. Load document, I'm telling it to load with the partition key at single key value. So this is now going to give me a key and a partition key, so super fast, efficient load for Azure Cosmos DB. My query is a little interesting because I can query based on text, based on an alias, based on a tag. So what I do is I use that find meta method that I showed you to grab the alias if it's there, and I just grab the documents. I'm done. It's just one load and that document summary is there. With a tag, I can also just grab it, but if I specify an author and a tag, I need to look at the intersection of those two results. I want things that have both the author and the tag name on it. And then the least efficient is when I'm searching on text, because I'm basically going out and looking at title, description, markdown, etc. And then I intersect it and prune it down based on if I'm also filtering on alias and otherwise. But you can see I'm just using language integrated query. I'm using a projection here to turn it into a document summary. I'm ordering it by title and returning it. Search authors is what we use in the type ahead dropdown as we're starting to key through. And again, that's something that changes infrequently enough. I would probably cache that. But in this case, I'm showing database performance by going to the database all the time. I'm just getting the aliases, and then I'm using a local contains so that I can use an invariant string conversion. You can actually pass a to lower to Cosmos DB, but I wanted the invariant. We've got search tags, which works the same. Update document, it's as simple as this. Context, tell Entity Framework we're updating the document, save the changes. This is loading the history, so it's basically looking at that document and grabbing all the audit files and turning them into a summary. And this is what loads the snapshot from an audit, and it's basically just getting the document snapshot. The most complex logic that I have is this handle metadata, because what I have to do is if you remove a tag from a document, I have to go to that tag and remove the document from the tag. This is where a relational database would just break the relationship. But in the case of a document database, I need to keep everything updated. This is where there are multiple ways to do this. I'm choosing to do it through code, and it's really not that difficult. It's basically find a tag that was removed, load that tag, look at the document, remove the document, and then it gets saved with the document update. All of these steps are basically using logic to remove that summary, and then it's just flagging that, hey, I updated this tag. If I look at a tag and the document's already removed, it doesn't get that flag, so it's not even touched. We go through and do this for tags that are deleted, tags that are added, because we automatically insert. That's just a context.add tag. Otherwise, it's modified and it gets the document summary. So there, we automatically on every save keep your tags and your aliases in sync so we can have those fast lookups and searches. So that is the short and long of the Planetary docs. I will show the repo link at the end of this presentation, but I want to drop back and have one more discussion before we close out this session, and that is Blazor WebAssembly. So one of the things when Blazor came out, Blazor allows you to write web applications with C#. And I had several people approach me and say, does EF Core run in Blazor WebAssembly? So the code is actually running in the browser. And the answer is yes, it will run. But the caveat is it has to follow the sandbox rules. The browser is sandbox and has security around it. And so the browser itself doesn't support connecting to a SQL port. And therefore, I can't use the SQL provider. I can't access the local file system, so SQLite used to be off limits, although now there's implementations that use browser storage for SQLite. But Cosmos DB is interesting because there's the opportunity to connect over an HTTPS protocol. It's not the most efficient way. The direct protocol is definitely faster, more efficient, but you can configure that. So I set out to say, is this even possible? And the answer is, it is possible. I can put EF Core in the browser and connect to Cosmos DB directly. I have to configure the client to use that gateway transport. But there is a caveat, and this is a very important caveat: security. Because the application is running in the browser, there is no way that I would want to store my Azure Cosmos DB key in the browser, even encrypted. Because you have to assume that if you're decrypting it to send it over the wire, the user can inspect that memory in their browser and they can gain control. And that key gives them control over the entire database. So that's a no-no. So in looking at this, I tried to come up with a way, is there a solution that is a workable solution? And we'll talk about that in a second. So the easy part is accessing the Cosmos client with the endpoint and the key. You get these client options, you tell it to use connection mode gateway, limit to endpoint true, and you're off with an HTTP connection. The hard part is that endpoint and that key. How do I specify those securely in the browser? Well, the answer I came up with looks like this, and this, I take full credit for this artwork, and you can see it's very readable. But basically the premise is this: Cosmos DB supports special tokens that give limited access. You can limit the access to a container, you can limit the operations, read or write, and they're ephemeral tokens. That means they expire. So if someone were to steal the token, first, they would only be able to operate under that token's permissions, so they couldn't control the whole database. Second, that token will eventually go away. So in this scenario, what we do is we secure the login to the application with Azure Active Directory. There's plenty of documentation on ASP.NET Core docs on how to do that. We have to have a service set up, and I show it using an ASP.NET Core Web API as well as Azure Functions, but there has to be a service that does have the protected credentials so it can go out to Cosmos DB and create the token. So what happens is you authenticate, and then your authenticated identity talks to the endpoint. The endpoint goes to Cosmos DB and gets that temporary token. then hands it back to the browser. The browser then uses that token as the access key for the connection, and it's able to access it. If you'd like to see code and how that works, my blog has a very in-depth post, and there's a follow-up blog that's linked to that shows the same thing with Azure Functions. Check that out and take a look at it. Again, my recommendation is to keep secrets safe and on the server and use that traditional method of exposing a GraphQL or a REST endpoint off your server and relay between Cosmos DB, but this is an intriguing possibility to explore. Having said that, the Planetary docs example you saw will be posted up at this GitHub repo, Jeremy Lickness Planetary docs. I am at Jeremy Lickness on Twitter. My direct messages are wide open. I'm always happy to answer questions and work with you on all things .NET data related and even some things that aren't. So thank you very much for your time and attention. I hope you're having a great time at the Azure Cosmos DB conference.